In this question, we told that an object moves in a straight line with velocity v for this time, and it's modeled by this equation here, and where a and t are positive constants. Outside this interval, the object is at rest. So we need to give a sketch for the variation of velocity with time. So first of all, we see that if we set this equals to 0, then solution will be t equals 0 and t equals t. So therefore, we must cross the x-axis, the time axis, at 0 and t. So from this reasoning, we can't eliminate anything, but just gets us to confirm stuff. Okay, next thing to note here is that this thing here, this expression here, is always positive, because when t is greater than 0, this is positive, and t minus t squared is a square, so it's always positive. Therefore, it must always lie above the x-axis. So this clearly lets us eliminate B and option E. Now, the difference here that we now need to consider the statement that outside this range here, the velocity is 0. So from this, we know that C is wrong. Let's now look at options A and D. Well, what is the difference between A and D? Well, the difference lies in these sections here. So in the section before the point here. So that's the difference here. So we can see that indeed it's steeper. So basically, what we want to see now is how does the gradient of V vary when t is close to 0. So this is the key here. So let's look at t. So we see here when t is very close to 0, well, this expression here is going to be very big when compared to that expression. So it's going to move faster up. One other way to think about it is as t gets bigger, while this one gets bigger, this one gets smaller. And since this is a square, it's this component that matters more. So as t gets bigger, the change in velocity is going to get smaller. Therefore, what we want is not something that's going up like that, but something that's going like that. So therefore, the answer is D. So we want to the next part. So in this question, we need to find an expression for the acceleration. So recall that the velocity was given by at times t minus big T squared. So now what we want to do is find the acceleration. Acceleration is equal to dv by dt. So first of all, let's go ahead and expand v. So this is at times t squared plus t squared minus 2att. And this is just at cubed plus at t squared minus 2att squared. Okay, so now let's differentiate this expression. So we get 3at squared plus at squared minus 4at capital T. So this is the acceleration. Let's see if we can factor this out now. Okay, so I'm going to remove a first. So it's going to give 3t squared minus 4tt plus t squared. Well, this can be factored out. This is just equal to 3t minus capital T and t minus big T. So therefore, our answer is D. So move on to the next part. Okay, so in this part of the question, we need to find the most negative acceleration of the object. So here we need to sketch the acceleration time graph. So this is the time. And we know the root is going to be at capital T and at t over 3. So somewhere here at t over 3. So therefore, we know whatever that thing looks like, the minimum point is going to be at the midpoint of those two lines by symmetry. So the midpoint of this now is what we need to find. So we know from this picture that this distance here is 2t over 3. Therefore, this distance here is just t over 3. Therefore, what we need to do is to sub in the coordinate of this point in our expression. Now, the coordinate of this point is simply t over 3 plus t over 3, which is 2t over 3. Let's sub that in. So we get a at the point 2t over 3 is equal to a times 2t over 3 minus t times 3 times 2t over 3 minus t. Okay, let's evaluate it. this is a. 2t over 3 minus t just gives minus t over 3. And here it gives, so here we can cancel this out. 2t minus t is just t. So this is minus a t squared over 3. Therefore, the answer is E. Okay, so in this question, we need to find the most positive acceleration of the object now. I brought back the sketch of the acceleration from before. So we know we only care about the portion between 0 and big T. So we can see from this diagram that the maximum acceleration is going to be when t equals 0. So all we need to do is sub in t equals 0 in our acceleration. Recall the acceleration was a times t minus big T and 3 t minus big T. So therefore, if I sub in t equals 0 in there, I'll just get a into minus t times minus t, which is just a capital T squared. Therefore, the answer is A. Okay, so in this question, we need to find the displacement of the object at t equals 2t. So we know after capital T here, the object is rest. So all we need to do, in fact, is to find the displacement till t equals capital T. Now, recall that the displacement under a velocity is the area under velocity time graph. So what we want is this area. So what we need to do is integrate this from 0 to t. So let's go ahead first of all and expand this again. So this is just at times t squared plus capital T squared minus 2tt, which is at cubed plus att squared minus 2at squared capital T. So what we need to do is to integrate that from 0 to capital T to an at cubed of at cubed at t squared minus 2at squared t with respect to time. Let's go ahead and do that. So this just gives at to the 4th over 4 plus a t squared over 2 plus 2at cubed t over 3, and that's all we have. So now we need just to put the limits 0 to t. Let's sub in capital T in it. We'll just get at 4th over 4th minus plus at 4 over 2 plus 2at 4th over 3. So let's add this together now. Let's put everything under 12. So we got 12. So it's going to be, this term here is going to give us 3. This term is going to give us 6. So 3 plus 6 gives 9. And this term here is going to give us 8. So 9 plus 8 is... sorry, I made a mistake here. Let me clarify that. So this here should be a minus sign. Just a silly slip, sorry. Remember here, so this is minus, and this is a minus. Let's do that again. So put everything over 12 now. So this is 4. So over 12, I must multiply by 3, so that gives 3. This gives 6. 3 plus 6 gives 9. 9 minus 8 gives 1. So this is going to be at 4th over 12, and the answer is C.